Hi, Assalamualaikum. I hope you are doing well today. My name is Nurul Fatin Ashikin binti Abdul Razak and my metric number is S58239. Today, I want to explain about assignment 1. For question 1 is structure of metal complex. According to the chemical electron series, fluorine is weak free ligand. Generally, this complex have lower electron count. When a structure has less than 18 electron count, it is considered electron deficient. That means the compound has empty valence orbital, making it electrophilic and extremely reactive. The ligand will donate electron to metal center to stabilize overall charge. The metal complex is found to be high spin complex. The hybrid state of cobalt is sp3d2. It is octahedral in shape. There is 4 unpaired electrons and it is paramagnetic in nature. In an octahedral geometry, the bond angle between the ligand is 90 degrees in a metal center. Other than that, octahedral complex have a coordination number of 6, meaning that there are 6 places around metal center where ligand fluorine can bind. In this complex, when crystal field splitting energy is small, the electrons are placed on the lower energy d orbital. This is classified as high spin and cannot pair up electron. Questions 2. This coordination compound has cobalt as the central transition metal and 6 fluoromonodentate ligand. Fluorine has a charge of -1 and the overall molecule has a charge of -3. Since there are 6 fluorines, the overall charge of fluorine is -6. The charge of cobalt will add to -6 so that the charge of the overall molecule is -3. Thus, we know that cobalt must have a charge of +3. The electron configurations of cobalt is 4s2 3d7. When observing cobalt 3 positive, we know that cobalt must lose 3 electrons. The first 2 to go are from the 4s orbital and cobalt becomes 4so3d7. Then the next electron leave the 3d orbital and the configuration becomes 4so3d6. Thus, we can see the 6 electrons that need to be appropriate to crystal field diagram. The pairing of these electrons depend on the ligand. Since fluorine is a weak ligand, it will be high spin complex. Questions 3 and questions 4. In addition, I will combine the explanation ligand name and complex name since they are related. To name a coordination compound, no matter whether the complex ion is the cation or the anion, always name the cation before the anion. Firstly, name the ligand first in alphabetical order, then the metal atom or ion. Note that the metal atom or ion is right before the ligand in the chemical formula. In this complex, the anion ligand is fluoro, the N with O. Secondly, Greek prefixes are used to designate the number of each type of ligand in the complex ion, di, tri, and tetra. Hence, the ligand in this complex already contains a Greek prefix which is hexa, meaning that contains 6 ionic ligands. After naming the ligand, name the central metal. The complex ion is an anion, so the name of the metal ends with the suffix -ate. Cobalt in a complex anion is called cobaltate. Following the name of the metal, the oxidation state of the metal in the complex is given as Roman numerical in parentheses. Since there are 6 fluoro binding with a complex ion, the charge on the complex ion must be -3. Since each ligand carries -1 charge, the oxidation number of cobalt is +3. Finally, this complex named as hexafluorocobaltate 3 ion. Questions 5. Preparations of metal complex. Synthesis of cobalt 3 complex. A solution of cobalt 2 acetate tetrahydrate in methanol was added dropwise to a solution of HL1 in acetone at room temperature. The color of the mixing solution turned brown immediately from light yellow. The solvent was partially evaporated for 2 weeks at room temperature and obtained several brown, neatly like single crystals suitable for X-ray crystallographic analysis. Question 6 is microstate and UV spectrum. The ground state term for a free ion with D6 configuration is shown. The electron field according Huang's rule and neglected the first pairing electron, so remaining is 4 unpaired electron. Total spin quantum number is 2, orbital quantum number is also 2. Then insert the value into the formula. However, the total angular momentum quantum number is 4. Finally, the ground state term for free electron with D6 configurations is 5d4. Thus, a D6 configuration will have 210 microstate like the table below. For UV vis absorption spectra, I will explain the UV vis absorption spectra of HL1 and the cobalt-3 complex. The examples were determined in 5 × 10⁻5 mol per liter HL1 in CH2Cl2 solution. Absorptions of the cobalt-3 complex were obviously different from those of HL1 as shown in figure. Compare with the complex of cobalt-3. An important feature of the absorption spectrum of HL1 was the 3 absorptions were observed at 241, 305, and 364 nanometer respectively. The latter absorption peaks were absent in spectrum of the cobalt-3 complex. The other absorption was at 241 nanometer of HL1 Schiff to 246 nanometer and 266 nanometer in the cobalt-3 complex, and a new unconspicuous absorption peak at 451 nanometer was observed in the cobalt-3 complex, which could be due to the DD transition of the cobalt-3 ion. The cobalt-3 complex with 3d6 electronic configuration would be assigned to 41G(F) to 41G(P). DD transition of cobalt-3 ion in octahedral environment. These observations were in line with common spectral features of D-block metal complex. The instance band around 451 nanometer was assigned for ligand to metal charge transfer LMCT transition. This pin allowed DD band indicates octahedral geometry around cobalt-3. The splitting of 3D level in the crystal field of the coordination compound causes DD electronic transition. Lastly, the applications of metal complex. Several cobalt compounds are used in chemical reactions as oxidation catalysts. Cobalt acetate is used for the conversions of xylene terephthalic acid, the precursor to the bulk polymer polyethylene terephthalate. Typical catalysts are the cobalt carboxylates known as cobalt soap. They are also used in paint and inks as drying agent through the oxidation of drying oils. The same carboxylates are used to improve the adhesion of the steel to rubber in steel belt radial tires. I think that's all for now. Thank you.